Introduction. Time is often treated as the most reliable feature of the universe, a steady, invisible current carrying everything forward. It defines change, anchors memory, and gives structure to every equation we trust. From the ticking of atomic clocks to the expansion of galaxies, time appears consistent, measurable, and absolute in its direction. And yet, when physicists examine it closely, something begins to feel incomplete. The deeper we look, the less time behaves like a simple dimension, and the more it resembles something fragile, perhaps even emergent. Equations that describe the universe with stunning precision often work just as well without time at all. At the smallest scales, the distinction between past and future dissolves. At the largest scales, time stretches, bends, and may not even have a clear beginning. There exists a growing, unsettling possibility, one that many physicists approach with caution. Not because it lacks mathematical foundation, but because of what it implies. That time, as we experience it, might not truly exist. What follows are 10 interconnected anomalies, ideas, and quiet inconsistencies that, together, suggest a deeper question. Are we moving through time? Or is time something we are constructing as we move? The first anomaly, the equations that don't need time. In the foundations of physics, time seems essential. But when researchers attempt to unify quantum mechanics with gravity, something strange happens. The most fundamental equation describing the universe at this level, the Wheeler-DeWitt equation, contains no time variable at all. It describes a universe that simply is. There is no past, no future, no flow. Just a static, complete structure. This presents an immediate contradiction. Everything we observe depends on change. Stars evolve, particles interact, thoughts form and fade. Yet the deepest mathematical description of reality appears indifferent to temporal progression. Some physicists argue this is just an incomplete framework. Others suspect something more radical. That time is not a fundamental ingredient of the universe, but a byproduct of something deeper, an emergent illusion arising from relationships between states. If that is true, then what we perceive as motion through time may be nothing more than the unfolding of a static structure, experienced sequentially by conscious observers. A second disturbance, the symmetry of time. At the microscopic level, the laws of physics exhibit an unsettling symmetry. Most fundamental interactions work the same, whether time moves forward or backward. If you recorded particles colliding and played the footage in reverse, the event would still obey the laws of physics. There is no built-in preference for before or after. And yet, our experience is entirely one-directional. We remember the past, not the future. We age forward, not backward. Entropy increases, systems decay, and processes appear irreversible. This contradiction between reversible laws and irreversible experience remains unresolved. The arrow of time is often explained through entropy, the tendency of systems to move toward disorder. But entropy itself doesn't explain why time flows. It merely describes a direction once that flow is assumed. So where does the direction come from? If the laws themselves are indifferent, then perhaps the flow of time is not written into reality, but imposed by the way information is processed within it. The third anomaly, the block universe. One interpretation of relativity suggests something deeply counterintuitive, that all moments in time, past, present, and future, exist simultaneously. This is known as the block universe. In this model, time does not flow. Instead, the universe is a four-dimensional structure where every event is fixed within space-time, like frames in a film that already exists in its entirety. The sensation of now moving forward is not a physical process. It is a feature of consciousness, scanning through a pre-existing structure. If this is true, then the future is not something that will happen. It is something that already exists, just as concretely as the past. This raises difficult questions. If every moment is already laid out, what does that mean for choice? For causality? For the very idea of change? And more subtly, if time does not flow, then what exactly is it that we are experiencing as movement? Another quiet contradiction, time dilation and relative reality. Relativity introduces another complication. Time does not pass at the same rate for everyone. Clocks tick differently depending on speed and gravity. An astronaut moving near the speed of light will age more slowly than someone on Earth. A clock placed near a massive object will run slower than one far away. There is no universal now. Events that appear simultaneous to one observer may not be simultaneous to another. This fractures the idea of a single, shared timeline. Instead, each observer carries their own version of time, shaped by their motion and position. If time were truly fundamental, we might expect it to behave consistently across the universe. Instead, it stretches and bends, adapting to perspective. This suggests that time may not be a fixed backdrop, but something more flexible,
perhaps even dependent on observation itself.
The fifth anomaly, quantum timelessness. At the quantum level, the situation becomes even more abstract. Certain interpretations of quantum mechanics imply that particles do not evolve through time in the classical sense. Instead, they exist in a superposition of possible states until an interaction, often described as a measurement, selects a particular outcome. Between these interactions, the notion of time becomes unclear. Some approaches to quantum gravity propose that time emerges only when systems become sufficiently complex, when interactions create a network of relationships that can be interpreted as sequential. In this view, time is not present at the smallest scales of reality. It appears only when enough structure exists to define change. If so, then time is not a universal feature of existence, but a property that arises under specific conditions. And outside those conditions, it may simply not exist. A deeper puzzle, the beginning of time. The origin of the universe is often described as the beginning of time itself, but this idea contains a paradox. If time began at the Big Bang, then asking what came before becomes meaningless, because before requires time. And yet, models of cosmology increasingly suggest that the Big Bang may not have been a true beginning. It could have been a transition, a phase change, or part of a larger structure. Some theories propose a cyclic universe where time loops or resets. Others suggest a multiverse where our timeline is just one branch among many. If time can begin, end, or loop, then it behaves less like a fundamental dimension and more like a feature of a specific system. This challenges our intuition. We tend to think of time as the stage on which events occur. But what if time is not the stage, but part of the play? The seventh disturbance, the illusion of the present. We experience a continuous now, a moving point that separates past from future. But physics offers no clear definition of this present moment. There is no universal boundary marking what is happening now across the universe. Due to relativity, different observers disagree on what counts as the present. This suggests that the present is not an objective feature of reality, but a subjective construction. Neuroscience supports this idea. The brain processes information with slight delays, integrating sensory input into a coherent experience that feels immediate but is actually assembled from fragments of the recent past. The now we experience may be less than a tenth of a second wide, a carefully constructed window. If the present is an illusion, then the flow of time, past to present to future, may also be a narrative created by consciousness. The eighth anomaly, entropy and the missing explanation. Entropy is often cited as the reason time moves forward, but this explanation hides a deeper mystery. Why did the universe begin in a state of such low entropy? The early universe was extraordinarily ordered, far more than random chance would suggest. This initial condition is what allows entropy to increase over time, giving us the arrow of time we observe. But physics does not explain why this low entropy beginning occurred. It is simply assumed. Without this special starting point, the distinction between past and future would disappear. Time would lose its direction. This implies that the flow of time depends on a very specific and unexplained condition at the origin of the universe, a condition that may not be fundamental, but contingent. The ninth idea, time as information. Some emerging theories suggest that time may be linked to information rather than motion. In these models, time is not something that flows, but something that is counted, the accumulation of changes in information states. Each interaction, each quantum event, updates the informational structure of the universe. What we perceive as time passing could be the result of tracking these updates. This reframes time entirely. Instead of being a dimension, it becomes a measure of change within a network of relationships. If no information changes, then from this perspective, time does not pass. This raises an unsettling possibility that time exists only where there is complexity, interaction, and observation. And in the absence of these, it may vanish completely. The final disturbance. The possibility that time is a construct. Taken individually, these anomalies can be explained or at least managed within existing theories. But together, they form a pattern. Time disappears from fundamental equations. It loses direction at small scales. It becomes relative under motion and gravity. It emerges only under certain conditions. It depends on entropy, which itself depends on unexplained initial states. It may be tied to information. It may be constructed by consciousness. At every level, time appears less stable than we assume. This leads to a possibility that many physicists consider, but rarely emphasize. That time is not a fundamental feature of the universe, but a construct, an emergent property arising from deeper, timeless laws. Not something we move through, but something we generate as we interpret reality. Conlucian.
If time is not fundamental, then our most basic intuitions about existence begin to shift. The past may not be gone. The future may not be unwritten. The present may not be a true boundary between them, but a perceptual artifact, a way for consciousness to navigate a reality that does not inherently flow. What we call change might be the comparison of static configurations. What we call motion could be the ordering of relationships within a structure that simply exists. And the sensation of time passing, the quiet, constant drift from one moment to the next, may not be a feature of the universe at all, but a feature of us. This does not make time unreal in a practical sense. We still measure it, rely on it, structure our lives around it, but its deeper nature may be far stranger than a simple dimension stretching from past to future. It may be something that emerges only when certain conditions are met, when complexity reaches a level where sequences can be perceived, when information changes in a way that can be tracked, when observers exist to interpret those changes. And beyond those conditions, there may be no time at all, just a universe that is complete, silent, and unmoving, not waiting, not progressing, simply existing. Thank you for watching Channel Entropy Files.